Hello everyone, and welcome to my talk on multidimensional browsing in virtual reality. My name is Tiger Cross, and I'm an undergraduate student at Imperial College London, and my colleagues are Thomas Heinis and Riccardo Bovo. In today's presentation, I will discuss my vision paper in which I talk about my application, which aims to allow users to browse web content in an immersive virtual reality environment. So first of all, what do we mean by multidimensional? Now, there's two areas that I'd like to address. First of all, we want the user to be able to freely interact with the content and manipulate items in their surroundings. And second of all, we want the information to be all around the user, as you can see in the diagram on the right here. And what's really important is that it's definitely not constrained into a single particular window. And what I mean by this is results can be just dotted around the user, but they're not stuck in one 2D square box altogether. So in terms of setting a bit of context, we're building this application for the web browsing and web search scenario. So a user is going to be looking for particular web pages, images, videos, but also maybe shopping content or map data. And we're building this for immersive virtual reality environments. And in order to explain what those are, it's basically a type of virtual reality environment in which the user is simulated in the entire environment. The user can't see any of the real world, and it is entirely simulated for them. And there may be interactions which seem like they are in reality. In terms of the device medium, we're looking at using a head-mounted device for this, particularly the Oculus Quest devices, which are untethered devices, and they work by projecting the simulated environment onto the user's retina. So let's discuss the motivation behind this application. First of all, let's take a look at what it's like browsing the web on desktop versus how it's currently like in VR applications. So as you can see in this screenshot, these desktop results are quite rich with information. There's a lot of potential links that a user can click on, or other data items that the user can explore. In contrast, this is Firefox VR, and it shows the results for the same search. There are only two results there, and going back to what I said earlier, the user is constrained to a single window in which the user can only scroll up or down, so in one dimension, essentially. And this is part of the motivation behind building this application. We wanted to kind of move away from this single linear set of results in a window. So summarizing the current state of the art, what we've seen so far tends to focus on semantic concepts for visualizing data in the research area. And other implementations, we haven't found that many really utilize the additional space in an immersive virtual reality environment, because a user does have all of that space. They're able to move their head around and look at different results. They can tilt their body, and they're in a full 360-degree three-dimensional environment. In terms of commercial implementations, we've seen that the majority of them tend to just port over what's available on a desktop or an Android. And this, again, limits them to that singular window with a list of results. So let's first take a look at some of the research implementations here. The one on the left is known as Subject Explorer 3D, which, as I said, focuses on semantic concepts. And it looks at linking data based on semantic relations. And the user can then point and fly through the data in order to explore. It doesn't focus as much on web data, and this was built for desktop VR as opposed to immersive virtual reality, which means that the 3D environment is simulated on a PC screen. On the right, you'll see Virtual Reality Lifelog Explorer, which is an application that was developed for immersive virtual reality environments, and it has the goal of allowing a user to search and explore a series of images that are collected over the period of a person's life log, which is, as I said, just a period of someone's time. In the commercial application side, we again looked at several available pieces of software. The first one on the left is Oculus Browser, which is Facebook's implementation that comes pre-installed on the Oculus headsets. As you can see, the user is typing using a form of interaction that's known as raycasting, which is where laser-like beams protrude from the controllers, and the user can use these to select characters on a keyboard in this case. On the right, we see Firefox Browser, which is displaying the search results we saw a few slides back. And in both of these implementations, as you can see, the user is limited to browsing within a single window. It is possible in the Oculus browser to create multiple windows. However, it's not possible to look at multiple at once. Based on the size of the window that's rendered, they pretty much take up your entire field of view, which again limits you to looking at a maximum of 2 or 3 results per search that you do. So now let's discuss the actual design of the application and what is actually going into the vision. Before just going ahead and saying, right, this is what we're doing, we had to consider what there was already in our design space. So we had to think about how we want users to interact with their environment. We could use the raycasting, which we saw on the previous slide with Oculus Browser. We could allow the user to pull themselves through the environment, or we could allow the user to mostly remain stationary and manipulate the data objects around them instead of having to move and risk them being cybersick. As we're building a web browsing application, we obviously had to have some form where the user could input a query. And the options here really came down to allowing them to input the query via voice search or via a keyboard. We found in literature that there is voice search has been shown to allow the user to type at 23.6 words per minute. And this beats several keyboard implementations. And there are 2 types of keyboard implementation which we predominantly encountered. One puts the keyboard at a distance and uses the laser beam-like interactions to select keys. The other projects a keyboard close to the user, which they can then have virtual hands in their virtual environment, which is projected over the top of their controllers, and they can use these to type. Furthermore, we considered different potential layouts for the data. We saw research which discussed laying out data in a sphere. This discussed it in an augmented reality context, which is where the user is able to still see some of the surrounding real objects, but also has some virtual simulations as well. The issue with this was that sometimes the real objects got in the way of some of the virtual projections. And this would not be the case in immersive virtual reality, considering everything is simulated. We also looked at amphitheater-style layouts, and we'll discuss the benefits of this layout on the next slide. And finally, we wanted to consider the different types of orderings that will apply on the different results, because obviously we didn't want to stick to that single-dimensional list. Most web browsers operate with that single-dimensional list just because they have the one metric, which is namely relevance, determined under the hood by the search APIs themselves. So in terms of our actual vision for the application, firstly, we would like the user to be able to freely move the results themselves. We didn't want to risk the user becoming disorientated in their environment. And we thought we would project the results around the user, and they may move them around and interact with them. And that way they're closer to the results. And at the same time, they can arrange them as they like. Secondly, we decided to offer the option for the user to search by both voice and keyboard. The type of keyboard is a virtual one where the user will be close to, since this in literature was shown to be much more efficient. However, we will prompt them to use voice slightly more, considering it's faster and easier. In terms of the data layout, we decided to go with an amphitheater-like structure. We found a particular article that demonstrated that this kind of structure was beneficial to the user's short-term memory. So in terms of remembering where particular results may have been in terms after a search. They'll be able to navigate much easier. And also we found potentially a sphere had the problem of enclosing the user and making them feel trapped, which we didn't want to do. As for the orderings, we will still have a primary axis which uses relevance, and this will be up and away from the user at a diagonal angle to them. However, we'll maintain a second ordering as well, which will depend on the result type. So for example, for images, it may be the size of the image, and for web content, it could be how long a particular article is to read. However, we want to make this as flexible as possible for the user. There are a couple of extended features that were inspired by the literature that we would also like to discuss. Firstly, the Oculus devices offer hand tracking capabilities, which would allow for much more precise interaction, and it would make things more akin to the real world. Eye tracking is present in some other types of head-mounted devices, which could be used to collect more relevance data on web sites or images and what people are actually looking at. Other literature has demonstrated head rotation amplification to be incredibly beneficial in this setting. If a user's field of view is restricted, they can still take advantage of all of the degrees of freedom and be able to look around in 360 degrees. And lastly, a potential thing we might consider is exploring other possible layouts, like the spherical one, which we mentioned. So now I'll just show you a quick video of a prototype that has been made. Here we see the user in the home landing page, surrounded by some template results. These are just placeholders at the moment, and all they have to do is hold their hand in front of them to open the menu. They have three options. They can hit a settings button, a history button, or press to search, and the menu will follow their hand. As we mentioned, they can choose to search with either a voice or a keyboard. And once they choose to search, the query will be transcribed as they speak in the voice scenario. Once they've executed their search, they'll see their results presented in an amphitheater-like layout. Results of different formats, such as videos, will be presented maybe behind them to the left, and images may be presented to the right. And we'll present visual cues to the user to demonstrate this. If they grab in between the results, they may scroll, and to prevent the problem of occlusion, which is where things get in the way of each other, we will decrease the alpha value of the actual results. The user may grab a particular result to detach it from the layout, and they can then place results in the air anywhere. Once they resize the results with both hands, they can then view the content on the web page, and it will be rendered in front of them based on where they placed it. So in terms of the work that is upcoming for this project, first of all, I'm going to go ahead and implement this in Unity. Following that, I will conduct a small user study, and with the results of that user study, I will then perform an evaluation on the application. As for the plan of the evaluation, we're aiming to do a small social distance user study because we're somewhat constrained by the pandemic. We're aiming for between 10 and 20 participants with differing ages and competencies. Some will have previously owned the Oculus Quest devices and others may not have. And we're aiming to use a questionnaire that has been shown to work, particularly for immersive virtual reality environments, as well as recording search-related metrics, such as the time it takes a user to reach a successful result. So overall, here we've presented a novel immersive virtual reality browser that makes use of all of the space and 3D dimensions that a user has in the environment. We try and move away from that linear window with just results on one axis, and we aim to tailor all the features to the particular environment rather than focus on semantic related results or desktop browsers. Thank you very much for listening to my talk, and if you have any questions or feedback, please get in touch with me. My email is down there, and I would appreciate it. Thank you. Goodbye.